everyone! I would like to show you how to use a back-to-back stem and leaf plot to compare data sets so you can make comparisons. As an example, a rower's stroke rate is the number of strokes per minute. And a rowing coach has been taking notes of stroke rates at 6 different races between Pulteney and Scotch to learn more about how they perform. And these are the results. So for example, Pulteney in one of their races? I don't know, I'm not a rower. Was 15 strokes per minute, and then 21 in the next one, 22, and so on. And these are the results for Scotch. And you'd better believe that in professional sports, doing data analysis like this is a multi-million-dollar industry, if not a multi-billion-dollar industry, because coaches want to perform better, and they can use data to perform better. Anyway, to compare these, it's just a list of numbers at the moment. Let's visualize it. Let's look at it. We'll create a back-to-back stem and leaf plot to compare the teams. So a stem and leaf plot will have a stem, and because it's back-to-back, I'll put results for Pulteney on the left and results for Scotch on the right. To make the list of stems, when I say stem, I mean, let's have a look here, and what's the smallest number I can see? 15. And what's the highest number I can see? 55. So the stems will be 1, 2, 3, 4, 5. The results that are in the 10s will go here, results that are in the 20s will go here, results that are in the 30s will go here, and so on. Okay, and if this doesn't make sense, go back and watch my earlier stem and leaf plot video. All right, now let's put the results for Scotch. The first result here is 22, 22. This is 32, so that's in the 30s, 32. Another 32, that result is in the 30s. There's a 2 here, 35, 39, 41. So far, this is the same as a normal stem and leaf plot that you already know how to do. And again, if you don't know how to do a normal stem and leaf plot, go back to my other video on it, or ask me, and I'll help you. Now let's do Pulteney. We've just done Scotch. Let's do Pulteney. So the first result is 15. That's in the 10s. 1, 5. The next one is 21. 21. The next result is 22. 22. 23. 23. 30. 3, 0. 55. 5, 5. There we go. So now it's just like a stem and leaf plot, but I can compare the two teams. For example, I can state the distribution for each team. Oh, by the way, I probably should have put a scale here to show that 3 line 2 is 32. The reason is, in another stem and leaf plot, maybe that might be 3.2. Maybe the results are very small. Or maybe that might represent 320. So that way we know that 3 line 2 means 32, and that this one is 41. So include a scale for your stem and leaf plots. All right, now let's state the distribution. Let's get a little reminder about distributions. And we'll start with Scotch, I think is easier. So imagine tilting this graph on its side. So I've got something that looks a bit like... So the left side and the right side look the same, the low side and the high side. Which of these distributions do you think matches Scotch's performance? I think Scotch matches symmetric. Both sides are the same. It's symmetric. But what about Pulteney? Pulteney is a little bit trickier. Where's my pen? There's my pen. So Pulteney, most results are clumped at the low side, and then the high side is really stretched out. I'll just try that a little bit better. So most results are clumped at the low side, and then there's one at the high side. So most results are low, but there's one, in this case, a rare one that's clumped, that's at the high side. So the positive side here is stretched out. So which distribution matches Pulteney? Pulteney's stroke rates are positively skewed because the positive end, the high end, is stretched out. and Scotch's stroke rates match a symmetric distribution. You can say that this is positively skewed on this side, and Scotch's stroke rates follow a symmetric distribution. Alright, let's look at other ways that we can compare the teams. We could calculate the median for each team. If you're not sure how to calculate the median, go back on my video on that where I show it. But basically, we want to find the middle number. We put them in order first. Are these numbers already sorted? Are they already in order? Yeah, so I don't need to sort them. That's already done. I put them in order and pick the middle one. In this case, if I divide it in two, is there one item in the middle or are there two items in the middle? There are two items in the middle. So for Poultney, I'm going to get these two items, these two data values, I should say, and I'm going to average them. So 22 plus 23, add them up and divide it by 2 to get the average. And what is halfway between 22 and 23? What's the answer here? It's 22.5. And we can do the same for Scotch as well. Conveniently, Scotch is also already ordered, so I can get the middle two numbers. Oh no, I've made a mistake. Look, 32, 35, 39, that's not right. It should be 32 and 35. Is that right? Yeah, 32 and 35. And what is 32 plus 35 divided by 2? It is 33.5. There we go. That's better. We can calculate the interquartile range for each team as well to get an idea about spread. So this will give us an idea about the average, sort of, the median, the middle, to get an idea about how consistent each team is. For Poultney, I could calculate the IQR, interquartile range. Again, if you're not sure how to do that, go back on my other video. But basically, this is the bottom half of the Poultney data, and the median of the bottom half is 21. The top half of the data is here, and the median of the top half is 30, so that's my upper quartile, my Q3. My interquartile range is Q3 minus Q1, and what will that be? What will Q3 minus Q1 be? It will be 30 take 21, which is 9. So that gives an idea about how spread out the Poultney results are. And I can do the same for Scotch as well. Q1 is 32. What's Q3 for Scotch? What's the median of the top half? It's 39. And what will the IQR be for Scotch? It's Q3 minus Q1. And what will that end up being? 39 take 32, which is 7. So you can see that Poultney's results are more spread out. The IQR, interquartile range, measures how consistent the results are or spread out. So we can make a comment on the differences between the teams based on all the data that we've found. Not based on our gut or our intuition, but based on real, objective, solid data. So what we can say is that Scotch generally have a faster stroke rate because what statistic can we use to back that up? We can use the median. Their median of, well, it says 37 here. It's actually 33.5, I think. 33.5. So the median gives you an idea about how high or low the results are in general. Their median of 33.5 is higher than Poultney's median of 22.5. You can see how this is a better answer than just saying faster stroke rate. We're giving a real reason for it, right? It's a really strong argument for why their stroke rate is better. And we can also comment on how consistent each team is. So, which is more consistent out of Poultney and Scotch? Which do you think is more consistent? Scotch is more consistent because, well, it looks more consistent, but let's be more objective than that. Let's base it on facts and numbers. Scotch is more consistent because their interquartile range of 7 is lower than Poultney's interquartile range of 9. And that, my friends, is how you can use data to analyze sporting performance, make recommendations for elite sporting teams and athletes. Give the questions a go, check your answers, Ask me for help if you need it. And good luck learning about comparing datasets. Bye, everyone.